Following on from the previous video, we're trying to integrate the secant of x. But in order for us to integrate the secant of x, we are going to consider this. So on a separate note, we are going to consider this. When you differentiate this, it will give you this thing here. And notice that that this thing here is exactly the same as this. So when you differentiate this, it will give you some bit here plus itself. So if you let u equals this thing here, so so when you differentiate the u, that's really us writing this here. When you differentiate the u, it will be this thing here. Okay, so when you differentiate the u, it will be itself. This is u here, because this is u here. So it will be itself times sec of x. So now if you look at this statement here, if you differentiate both sides, sorry, if you divide both sides by u, you will get u prime over u equals sec sec of x. So now we are at this stage here. We are now at this stage here. Okay, we are now at this stage here. So in calculus, always try and keep an eye out always keep an eye out for something of this form here, where you have u and then you have the derivative right on top of the fraction. So so always keep an eye out on this, because if I were, well, any time that you see some sort of bubble over, and then the bubble at the top is the derivative of the bubble at the bottom, then think of logs. Think of the natural log, because if I were to ask you to differentiate this, let's say 3x squared plus 4x. Okay, so if I were to ask you to differentiate this, you would do this. You would do this 1 over the bubble will stay intact. So that will be x squared plus 4x, and then we've got to times with the derivative of the bubble itself, the derivative of the bubble. So what's really happening here is that you can see that what's really happening is that if I were to ask you to differentiate this natural log of the bubble here, if you were to differentiate this, it will give you this. It would be 1 over the bubble itself times the derivative of the bubble itself. Now this thing here gets multiplied to the top. That will be bubble prime over the bubble. So this thing here is of the same form as this. So hang on. So what we've got here is if you have this, if you try and differentiate this, it will give you this 1 over the bubble itself times the bubble prime. So that's really the same as the bubble prime over the bubble here. So that's really of this form here. So if you have something like this, then you can say if you integrate it, it will be the natural log of the bubble. So the point here is that once we've got this statement here, we can integrate both sides. Integrate both sides. Well, integrating this will be, well, if I were to give you this, bubble prime over bubble here, if you integrate this, it will be the natural log of the bubble. Because if you start with this, differentiate it, it will give you this thing here. So if you have this thing here, then if you integrate it, it will give you this thing here. The point is that if you integrate this, if you integrate both sides, it will give you this. It will give you this. So integrate this, it will be the natural log of u here plus c, and then so integrate both sides, it will then give you this thing here. So you can see that this. So you can see that when you have when you try and integrate this, it will be this thing here. Okay, so when you integrate it, it will be this thing. So basically, I've just swapped these over. Okay, and don't forget earlier we said let u equals this thing. Earlier, or in the previous video, we said let u equals this thing here. So once you get to this stage here, once you get to this stage here, you can put the u back into here and then switch these two over. move this to the right, move this to the left. That will then give you this. So when you integrate this, it will give you this whole thing here. Okay?